In this video, we're going to get you ready to do assignment number 5, which is word problems with asymptotes. Our objective here is to interpret horizontal and vertical asymptotes in the context of a real-world situation. And the homework assignment we're looking at is section 4.3, and specifically the homework is 73, 74, 79, and 81. But on this video, we are actually going to work through number 73, and then we're going to do number 80. And then the rest will be your homework to finish on your own. All right, so here's number 73. And in number 73, we're told that we have an insect population in millions is modeled by this function here, f of x equals 10x plus 1 over x plus 1. We want to remember that x right here is measured in months, which means f of x is our population in millions. So this right here is our f of x. All right, step 1 says graph it in the window 0, 14 by 0, 14. When they write it like this in our book, 0 is actually our x min, and 14 is our x max. This one is our y min, and this y is our y max. All right, so let's get ready to put it in our calculator. I'll bring this over so I can see the equation. And the first thing we need to note is that we need to think of having parentheses around the top and the bottom so that we divide the entire numerator by the entire denominator. Now I just want to point out this is important because if I have 10x plus 1 over x plus 1, if I enter it like this in my calculator thinks I'm doing this. And that is not what we want. So we need to make sure we use parentheses. All right, here we go. We've got parenthesis 10 x plus 1 divide by parenthesis x plus 1. You probably want to pause and do this on your calculator as well. When we go to window, we're going to go from 0 to 14. Then we'll go down to y min. Again, 0 to 14. And we hit graph. All right, so here's our graph. And as we go along here, we're asked to find the equation of the horizontal asymptote. Let me just grab this graph down here. And I want you to see that there seems to be a horizontal line that we're not going past. So if I were to put it in up here somewhere, it's somewhere along here where it's approaching some horizontal line, and I want to see what that line is. So I'm going to go back to my calculator and hit trace, and I'm going to move along here. And I'm going to watch my y values. And I see it's at 9.08. And I can keep going along here. If I go long enough, it'll actually go off the side of the screen. And so I'm up to 9.4. And there you go. It keeps going. It's flashing. Okay, I think I stopped. The question is, it looks like, is it 9.5? Is it 10? I can go to my table too and check this out. So let's go at 0 and let's go up by 10s on my table. And I go to my table and there we go. I'm up to 60 and I'm at 9.8. And as I scroll down this, I'm thinking it's never going to get bigger than 10, and that's what it's looking like. So here I'm already down to 470, and I still haven't hit 10. So we're going to say that the equation of my horizontal asymptote is y equals 10. All right, we're ready for part B. It says determine the initial insect population. Well, initial would be the beginning, and the beginning is when x equals 0. So we're going to plug it in there. So f of 0 equals, and we plug it in, 10 times 0 plus 1 over 0 plus 1, and we get 1. And for a moment you might think, wait a second, how can I go from one fish and increase in population, but then I go up here and see my units, and I see, oh, it's 1 million insects. All right, so that was my initial population, was 1 million insects. And what happens after several months? Well, let's look at our graph. It's going up. All right, so my population increases to almost 10 million insects. Remember this 10 we got here? That's what it's increasing to, but it's not to 10 insects, it's to 10 million insects. The last step asks me to interpret the horizontal asymptote. Well, in interpreting, I have to think, well, why is it not going past 10 million? So we might say something like the ecosystem, or at least that's the word some people used in class, I like it. The ecosystem does not support more than 10 million insects. The ecosystem does not support more than 10 million insects. So we kind of get to a point where the births and deaths of insects stay at an equilibrium, and that seems to be at 10 million. Before that, the population grows. All right, so we've got our first problem done, and we're ready to move on to number 80. Let's look at this one. In this one, we're told that the cost-benefit function C computes the cost in millions of dollars of implementing a city recycling project when X% of citizens participate. All right, let's just pay attention. X is the percentage of participation, and C is the cost in millions. All right, first thing, asks us to graph it again. So let's go over here, and we're going to go into our y equals. And we've got 1.2x divided by, we want to divide by the entire denominator, so 100 minus x. You might wonder why I didn't put parentheses around the top. That's because there was no plus or minus, so it doesn't matter. But if you want to be careful, you can always put parentheses around the top. It's not a bad idea. So we could put parentheses around the 1.2x, and then also around the bottom, the 100 minus x. All right, and then they gave us our window, 0 to 100. So let's put that in our window, 0 to 100, and also from 0 to 10. And there we go, here's our graph. And it asks us in our first question to interpret the graph as x approaches 100. So here's our graph, and it appears to be going up, and the question is how far up? I'm actually going to change the window and make that y max quite a bit bigger. Let's actually make it go all the way up to 100. And you're going to see that my graph, look at that, right here, it shoots way up. In fact, this thing is heading up to infinity. So as x approaches 100, my cost approaches infinity. So as x approaches 100, cost approaches infinity. Now, we're going to make sense of this. The reason is we're talking about 100% participation. And basically, this is telling us 100% participation is impossible or incredibly costly. Is impossible or incredibly costly. All right, let's go to B. In B, it asks us if 75% participation is expected, determine the cost. So see, 75% participation, 75 goes in for x, because x is percent. That's my x. So I just need to find C of 75. And I'm going to go to my calculator. And I'm going to just plug in 75. So I'm going to hit trace, 75, enter, and there it is right there. So when x is 75, y is 3.6. Or if we think of our units, it's $3.6 million. So the cost for 75% participation is $3.6 million. Next, I'm told that the city plans to spend $5 million on the project. That's their cost. That means we're saying 5 equals 1.2x over 100 minus x. And it says estimate this graphically. So let's go take a look at our graph. And you'll recall when we've done this before, we can actually go into our y equals and put in a 5 for y2. So when I hit graph, I see where they intersect right there. And I'm going to hit second calc, and I'm going to go for an intersection point there. Press enter a couple times. And I can see there's my x that goes with a y of 5, 80.64. So x equals 80.64%, which is kind of incredible if you think about it. If you could get 75% participation for 3.6 million, and you spend another 1.4 million, you only went up from 75 to 80%. You have to wonder, was it really worth it? All right, our last step, it says to solve analytically. Analytically is another word for saying show your algebraic work. So let's do that. We're going to take this equation. First step, we'll cross multiply. 5 times 100 minus x equals 1.2x. We get 500 minus 5x equals 1.2x. Add 5x. 500 equals 6.2x. And when you divide, let's see, second quit here. When we divide 500 divided by 6.2, you're going to find out, look at that, the same answer we had before, 80.64%. All right, that gives you, gets you started on this assignment. We've done 73 and 80. Now you just need to do 74, 79, and 81. Good luck.